Imagine you could accidentally burn down your house, press a button, and have an identical copy rebuilt in an hour. Same layout, same paint, even the coffee maker in the exact spot. That sounds like science fiction. But in the digital world, people do the equivalent every day. The trick is a machine-readable blueprint, a recipe that recreates the exact house at the push of a button. A few years ago, my friend Maya moved cities and described the chaos of packing everything room by room. She spent weekends trying to remember which box had the kitchen towels, where she stored spare light bulbs, and whether the bedside lamp went in the den or the primary bedroom. She told me, if only I had a checklist that rebuilt the house for me. I laughed. But that checklist exists in tech, and it's called infrastructure as code. Think about a house. Usually, when you build or remodel, a contractor follows blueprints, precise drawings, listings of materials, measurements. Now imagine those blueprints aren't just paper. They're a file a machine can read. Instead of a person putting each screw in by hand, you feed the blueprint to a factory that pours the footings, sets the studs, installs plumbing and wiring, and hands you the finished house. That's the core idea of infrastructure as code, treating your servers, networks, and configuration like a house you can rebuild automatically. So, what is infrastructure as code in plain words? It's writing down all the instructions your systems need, what servers to run, how much memory they should have, what software they need, how they talk to each other, in files that computers can read and act on. Instead of clicking around a dashboard, you write the recipe. Then, when you run that recipe, the cloud or your tools build the environment exactly how you described. Let's unpack that with our house analogy so the pieces never feel abstract. The rooms are your different services. A living room might be a web server, the kitchen a database, and the garage a cache. The electrical plan is the network rules. The contractor's schedule is the order of steps, but you don't have to micromanage every hammer strike. You tell the machine the final layout, and it works out the details. That's called a declarative style. You describe the desired result, not how to perform every tiny action. Why is this useful? First, repeatability. When you build a house by hand, everyone looks a bit different. With a blueprint the factory follows, every copy is the same. In the digital world, this means you can recreate staging and production environments that behave identically. No more, it works on my laptop excuses, because the architecture is built from the same recipe. Second, speed. Rebuilding by hand takes time. Pressing the button runs the recipe in minutes. If you need 10 identical houses for an event, or 10 identical test servers for development, you no longer spend days copying settings. This matters when teams want to test fast or scale quickly after a sudden surge of visitors. Third, safety. A human can forget a safety check, misplace a screw, or set the wrong firewall setting. A tested blueprint reduces those human errors. You can also version your blueprints, like saving earlier drafts of your house plan. If a new blueprint introduces mistakes, you roll back to the last good version and rebuild the previous house exactly as it was. Let me give you 2 everyday examples to make this concrete. Example 1. Your neighborhood bakery runs a website and takes orders online. On a busy holiday, they need more capacity. With infrastructure as code, the owner has a blueprint that says, create 3 web servers, 1 database with daily backups, a load balancer, and a CDN for images. When traffic spikes, they run the blueprint to spin up more servers, and when traffic drops, they run a scaled-down blueprint. No one on the team needs to memorize VPN settings or firewall rules. Example 2. Imagine you're moving to a new apartment and you're obsessive about your workspace setup. Second monitor at eye level, keyboard tray, a specific Wi-Fi name and password, and the printer on the left. You write a move file that lists every item and its place. On moving day, instead of rummaging for boxes, you follow the file. It tells the movers what goes where. In tech, teams do this when they onboard new developers. A recipe provisions a laptop environment, installs the exact tools, and connects it to the right services. New hires are productive on day one. A couple of small terms worth defining, because they matter and they're easier than they sound. Idempotence is a word you'll hear. It means you can run the same recipe many times and get the same result. If you told the factory to build your house and ran it again, the factory wouldn't duplicate the house on top of the first one. It would ensure the house matches the blueprint. Immutable infrastructure is another phrase. It's the idea that instead of changing a live server, you replace it with a new one built from the recipe. This is like swapping an old room module for a freshly built, tested room, rather than trying to renovate while people are still living in it. Now, this isn't magic, and there are trade-offs. Just like writing a perfect blueprint for a house takes time up front, writing clear, tested infrastructure recipes takes effort. You need to think about how pieces fit together, permissions, and the data that must be preserved when you rebuild. But that upfront work pays off with fewer surprises, faster recovery after failures, and a smoother team handoff. Another useful detail: because the blueprints are files, they can live in the same place as your code, under version control. That means your infrastructure can be reviewed, tracked, and shared just like any other document. If a teammate changes the blueprint and it breaks the site, you can see exactly when and why, and revert the change. It's accountability and history wrapped into one file folder. Let's return to Maya's move. If she had a machine-readable checklist, her new place would have been set up the moment the movers finished carrying boxes. She could have iterated on the plan. Try a different lamp here, move the coffee maker there, and if she didn't like it, roll back. That's how teams using infrastructure as code operate. They treat their systems like places that can be rebuilt, experimented with, and restored quickly. One favorite real-world moment I saw was during a simulated outage exercise at a small startup. They intentionally took down their primary database region to test resilience. Because every environment could be rebuilt from blueprints, the team spun up a replacement in a second region in less than an hour, restored data from automated backups, and validated the users could still place orders. The exercise revealed lessons: a misconfigured permission here, a missing backup schedule there. And after fixing the blueprint, the system was stronger than before. The cost of testing was low because rebuilding was routine. So, what should you take away? Infrastructure as code is a mindset and a set of practices that treat digital systems as rebuildable artifacts. The blueprint metaphor helps because it makes invisible systems feel tangible. If you can imagine blueprints for every room, every light switch, and every appliance, you'll see why teams prefer files they can run instead of relying on manual setup. Recap: instead of rebuilding a house room by hand, you have a machine-readable blueprint, a recipe, that recreates the exact house at the push of a button. That makes your systems repeatable, fast to scale, safer to change, easy to test, and simple to recover. It takes work up front, but it converts chaos into predictable outcomes. If you're curious where to start, begin small. Write a blueprint that creates one tiny part of your system. Test it and iterate. Over time, you'll stitch those pieces together into a reliable plan that feels a lot like owning a factory that builds your digital house whenever you need it. Thanks for listening. I hope the house and blueprint picture helps the next time someone says infrastructure as code. If you enjoyed this story, like and subscribe for more friendly explainers about cloud and DevOps. It helps us and keeps videos coming.